Welcome back to the bench. We've got a couple of Kaoss Pads. We're going to focus on this one today. The left output is much quieter, as you can see here in the purple. The blue is the right output. And it looks like that the output is actually filtered as well as being low in volume. And this one has got a nick in it. I'm not sure whether that pad is sensitive or what's going on, so that'll be for another video. Let's get her open. That's very nicely put together. Ribbon cables are actually glued down. Looks like a bit of rework there. I'm going to have to focus our attention onto this area here. This is where the input comes in. I'm sure this op amp will flip the signal up so it's unipolar. Not sure why there's missing a footprint there. Not quite sure what was going on. Okay, I'll have to go and find a schematic. Yeah, and that was quite easy to find. Nice little manual, shows you how it's all connected together, which is cool. This is the analog section that we're interested in. So if I zoom in here, we can see the phono line inputs. They're coming in here, and they get through to these op amps, which go through a connector by the look of it. So we'll just check the output of these op amps first. And we can check pin 1. Looking good, and pin 7, so everything's good there. So now I think we can jump to the input of the analog to digital converter here. Comes to another set of op amps, but there's some caps just on the inputs here, so we can measure both either side of the terminals. So there we can see the input and the output and the input and the output, so they're all looking exactly right. So the signal's getting to the micro, okay, so I need to check the output. And if we scroll along here, there's the digital to audio converter. This is the analog outputs. And they come also up to the headphone control as well. So let's check the outputs of the DAC. These two caps, perfect place to check. So we'll check the input to that cap, and then the right hand side, so they're both the same. Ooh, the left hand signal is a sine wave and the right hand is a square wave. So yeah, we're definitely losing the signal at that point. So I just measured this cap in circuit with my capacitor meter, and it did show as in circuit leaky. The right hand channel didn't say that. So let's just whip this out and see if it still says leaky once we've got it out. And I'm just kind of applying a little bit of heat and sort of wobbling the legs up. You don't want to rip the pads off, so be very gentle, but with a little bit of wobbling around we can take it off. I think I'm going to get a smaller tip for when I put the new one back in, and we'll just flatten out that there. So we'll just check this capacitor. It's quite small to get your hands on, and out of circuit. Yep, in circuit leaky. So that cap is definitely a goner. Excellent. So I do have some slightly bigger caps, the same value, 10 microfarad. As you can see, it's slightly bigger footprint, but I think I can get that on there. Just give it a bit of a clean. And I'm going to add a bit of solder to the most difficult pad to get to, which is the one next to the other capacitor. Just make sure that this side is flat. And I will build up some solder on this pad because it's the closest one to that cap. That'll be the easiest one to put on first. So it's a bit difficult whilst the camera's in the way here, but if I line that up there, apply a bit of heat, and you'll feel it sink down. Hold it flat. I then like to just press down on the cap, apply some more heat, and make sure the cap's level. And you can see there that the leg's looking good to solder on the other side. So we'll just apply some solder, let that cool down, and then just reflow this side just to be sure. Okay, so this is the signal input coming in. I've wired it all up to my scope. This is the left output, and this is the right output, which now match. Looks really good. Just thought, one cap wrong. No problem. Happy days.